Open your cerebral cortex and shift your lobes into upper beta phase, because you are going to have Bitcoin knowledge transmitted directly into your vestibulocochlear. Your host at Bitcoin Knowledge is Trace Mayer, an early Bitcoin advocate since it cost $0.25, but this is not intended to be investment advice. A doctor of jurisprudence, but this is definitely not legal advice. And an investor in core cryptocurrency infrastructure, including Armory, BitPay, Kraken, and Mitagio, but this is not a recommendation of those services. Here, you get fed via direct mind download with pure and free Bitcoin knowledge.
Welcome back to the Bitcoin Knowledge Podcast. In episode 2 of A Week with Adam Back, we're going to be talking about some of the other people who have been instrumental in making Bitcoin a success. As he talked about in episode 1, he built on top of a lot of other people's work. And isn't that really how it happens in our science and technical fields? So, Dr. Back, thank you for coming back on the podcast. And when we're looking at some of the other people who have been instrumental in making Bitcoin a success, who would you kind of start with, besides Satoshi Nakamoto himself?
Yeah, so, once I really got interested in Bitcoin in sort of early 2013 and dove in like everybody else and read everything that was available. And at some point in time, you kind of run out of information you can read, and you still have many questions because some of the documentation is not that in depth or doesn't answer the questions sort of full extent. And so what people end up doing is ferreting out where the kind of brain trust and the gurus are hanging out, and that turns out to be, as I found, the Bitcoin Wizards IRC channel. So I went on there and started asking a bunch of questions and filled in the gaps in my understanding about the low-level protocol messages and some of the sort of implementation or design principles that are not otherwise documented. And so I got to know all these people who are actually sort of moving Bitcoin forward and improving it and streamlining and optimizing and adding novel features to it to improve smart contracting and so forth. And so I have to qualify to say that, because I started into this in 2013, there were some characters who I understand were actively involved earlier in Bitcoin who I didn't necessarily get to know. So I hear, for example, Sirius did a lot of work, and I'm sure there are many others. It's just that they were not so active anymore by the time I got in there, so I didn't interact with them and find out what parts of the system they designed or implemented and so forth. So in terms of people who I interacted with and later actually became colleagues with Dr. Peter Wooler, and so
why is Dr. Woolley SEPA, I've been really impressed with a lot of his work too. Why would he be the first one you bring up?
He has a very deep understanding of all the protocol details, but is also very focused on actually implementing and coding and making kind of, implementing major features in the code and doing major refactors and so on. So I think he's potentially been the most influential in terms of the actual hands-on code and doing re-architecting of the code base, going back to the initial release, some factors of Bitcoin are now 2 orders of magnitude faster and more efficient than they were. So
orders of magnitude
like literally
faster.
100 times, yeah.
Wow.
So, the initial code was...
and does that increase Bitcoin's scalability?
Yes, it does. So it's not always understood that scalability is not just about bandwidth, but also about the CPU utilization, the memory utilization, and the complexity of how those resources scale with use. So, we can say that the network utilization scales with order n squared, but there are also, CPU utilization in terms of validating the signatures and memory utilization in terms of data structures. And some of those things also scale non-linearly. So as the utilization level goes up, at the beginning, the blocks would have been quite empty because there were very few transactions initially. The early Bitcoin functioned just fine, but that was because it was lightly used. If it had seen today's use back then, it probably would have, various things would have gone wrong, or things would have crashed, or memory would have been used up, or it would have become bogged down and taken longer and longer to process blocks, and we would have seen, so let's say, higher orphan rates and so on. So without, going back and retrofitting the characteristics and doing the analysis, I can't say exactly what would have gone wrong, but clearly that kind of difference in performance is huge and would affect things.
Yeah, because I mean, we're adding a block every 10 minutes, and so it kind of grows in this huge, unmanageable blockchain.
Right. I mean, even today, the latency that you're experiencing as a miner is quite important for your profitability, and so the design of Bitcoin, this is kind of one of the things you find by talking to people who understand the protocol details, is the parameters are not random. They're probably presumably quite carefully modeled by Satoshi, in the sense that that 10-minute interval is balanced with the propagation delay of sending out the final mined block into the network. And so people have said kind of rule of thumb things like maybe 10 to 15 seconds to broadcast a block through the network. And if you balance that against the 10-minute block time, you come out around. So there's a possibility, because it's a distributed system. So there's no kind of unified correct time, which is one of the concepts you see in distributed system. You can't guarantee reliable synchronized time. So there's a possibility for two miners to find a block at the same time before learning that somebody else has mined one. So it may not be exactly the same time, but if it was within 10 seconds and you don't hear about the block for 15 seconds, then that's effectively the same time. And then those two blocks will go out into the network and only one can win. And there's a disambiguation protocol. But that block that doesn't win, that's a loss of profitability for the miner who mined it. They lose those 50 or now 25 Bitcoins. And that's quite expensive. And so that's called the orphan rate informally, though Peter Willer tells me this is actually an incorrect terminology in a technical level. It's a kind of misunderstanding of some other principle. But it's become the kind of de facto way to say these things. And so that means the miners are quite focused on minimizing their orphan rate or wasted blocks. So even today, there are two delays involved. One is to receive the block, and the next one is to validate the block. And even today, the work to validate the block is non-trivial, and the characteristics of block validation are actually also non-linear. So it depends on what kind of transactions are in the block and how they're structured. And, so for example, over the last few months, there was some stress tests in the network where people were sending lots of teeny transactions around, and somebody mined a block with many, many small dust level payments in a single, almost 1 megabyte transaction. And that transaction was pretty expensive to validate. It took tens of seconds to validate, even, on today's CPUs. So that shows it can be a factor. And, so you have to consider also in security systems, not the average case, but the worst case. So, if there's an advantage somebody can create for themselves economically or in attacking the system to create something that's an outlier, like an optimally malicious block, which would take everybody else a really long time to validate, but which they could validate instantly because they created it and they trust themselves. You have to consider the worst case also. So there's also validation. When you want to make the validation criteria for making an upgrade, you have to go and figure out what the worst cases are and make sure they're safe. So in terms of, the performance throughput, I don't think that was exactly the CPU bottleneck, but, for example, Peter Willer again has been working with Gregory Maxwell over the last year or so on re-implementation, highly optimized implementation of the DSA library. So there's a library called libsec P256K1, which is a reference to the NIST standard for elliptic curve signatures. And using a combination of sort of hand-coded assembly, implementing existing academic papers for DSA optimization, some of which I don't think had been implemented in deployed systems before. And also Gregory Maxwell was able to find a brand new algorithmic optimization. So at this stage, the libsec P library is 6 to 8 times faster on a CPU than the previous OpenSSL library, which is also hand optimized in assembler. So that's quite impressive.
Wow. So there's another major gain or improvement that Dr. Woolley's found for us.
Right. So, that was a result of, many, many hundreds of hours of kind of painstaking testing. So, actually in the course of testing libsec P, Gregory Maxwell and Peter Willer were able to find an actual bug in OpenSSL where OpenSSL flat out produced the wrong value in some kind of fringe case. And they do this using a kind of semi-automated form of rigorous testing of implementations of anything, in fact, but in this case, a cryptographic primitive. And the idea is to sort of do some kind of fuzz testing, but guided to focus on ranges where there could be problems. So using that approach, they were able to, exhaustively test a very large search space, which would be too expensive to fully, to test all permutations of. And through that, they found a bug in OpenSSL, which was actually submitted to the OpenSSL repository and accepted as a fix. But that was...
so they're fixing other people's problems too.
The focus was actually to have extremely high assurance of the correctness of this code, because it mustn't just be fast, but it must be absolutely correct. And I think right now he's doing an additional form of test to perform a kind of automated algorithmic proof that it's a full group using a library by Dr. Tanya Lan and Dr. Bernstein, which provides a kind of mathematical proof using the SAGE computer-aided algebra package to prove that the implementation is correctly implementing and doesn't have any kind of doesn't get trapped in a subgroup, I guess is the main thing. So he's doing that as an additional kind of validation, and at this stage it's fairly close to being deployed in an upcoming version of Bitcoin, and to give us thereby, a big boost in block validation speed. And that will also enable, there's a discussion of improving Bitcoin's throughput by increasing the block size a little. So that kind of, quite major leap in validation, the CPU bottleneck of validation will help there.
Now, you mentioned Greg Maxwell. Gosh, I mean, what has he not had his fingers in?
Yeah.
In Bitcoin.
So
I mean, tell me a little bit about this character.
So he's a very, very smart guy, and he's very inventive, and he's very knowledgeable about cryptography and cryptography protocols, and reads all kind of papers. And so the experience that you have, getting into Bitcoin in 2013, at least I have, is I have an idea like, oh, you could do this, and you go mention it on Bitcoin Wizards, or you go search it, and, 9 times out of 10, somebody's already invented it. And, 7 times out of 10, that somebody was Greg Maxwell. So this is a kind of pattern that he's very inventive, and he comes up with, many of the interesting improvements or extensions or use cases.
Well, can you name a couple?
So he came up with the CoinJoin proposal.
Okay.
And he also invented something using snarks to make a form of sidechain, but using snarks. And so when I started exploring how you could implement sidechains, I proposed a kind of a one-way pegged sidechain. And, in talking through with him, he was able to combine that at some point with the realization that the two-way component of the snark, he called the snark thing something about a witness. I've forgotten his name right now. And he was able to extract that separately from the snark, so you could get the two-way peg without snarks. So he had a big part to play in making the sidechain technology work.
Which you consider one of the greatest innovations in this financial technology and blockchain technology.
I think that's a big deal, because it allows you to introduce modularity and reduce complexity, and sort of therefore, if you can make a separate subsystem with a security firewall from Bitcoin, people can go and implement interesting things on it. So I'd come up with and proposed this confidential transactions concept and posted it on the Bitcoin talk forum going back earlier in 2013. And so in terms of actually implementing that was sort of a joint work between Peter Wuller on the library side and Gregory Maxwell to design the protocol. And as part of designing the protocol, he made an extension to sort of extended the concept of a hash-based ring signature. So this is an existing academic paper on ring signatures that are half the size of other elliptic curve-based ring signatures. It uses a clever trick involving a ring of hashes. And so, yeah.
Really?
Anyway, so Gregory managed to sort of combine that and make a sort of so a ring signature is basically one out of a range of signers could have signed, and you can't tell which one. So there's a kind of or in there, A or B or C signed, and he was able to generalize that into a network of ands and ors. So you could have A or B or C, and then an and D or E or F, and then another and. Mm-hmm. And so that structure, he called it a Borromean signature, because if you look up a Borromean thing, it's a kind of it's a graphic with an interlocking ring of circles. So just graphically, that's where the name came from. And that is particularly used as part of the range proof, which is part of the confidential transactions, which we're going to be talking about in a later episode.
Right, in episode 3.
So that enables us to shrink the confidential transaction and make it that bit more space efficient and computationally efficient. He also made the observation, actually, with the confidential transactions that you could, the range proof could also encode a message. So you could kind of reuse the space as an application message transport. And he went and implemented that as well, and wrote a kind of a paper with PhD candidate Andrew Polstra describing the ring signature mechanism and confidential transactions.
Now, we're herding all these cats. Somebody's got to keep the cats herded. Satoshi handed off the project to Gavin Andreessen. Well, so he handed it off to Gavin, and then Gavin later handed it off to Dr. Vladimir Vanderlaan, I think.
Yes, that's right.
And let's see, we actually have a quote from CoinDesk from Dr. Vladimir. Quote, I had noticed that Gavin had been much less active in the GitHub project lately, but I did not expect him to step down as lead developer. But it makes sense. There is a lot more theoretical work with regard to Bitcoin and cryptocurrency in general, making it a full-time job just to keep up with that and giving talks, traveling and such. On the other hand, I've been effectively the maintainer of the code for quite a while. In practice, nothing changes. So that was from April of 2014. So how about Gavin and Dr. Vanderlaan? What have they really been doing as the lead developers, as these kind of maintainers?
So there's this concept in Bitcoin. People talk about a core developer, and there are two potential interpretations. So one of them is, the most strict one is commit access. So there's a GitHub repository, and people have authorization to check in code. And that's a kind of, housekeeping role. And originally there was only Satoshi, and as he was preparing to step out of the project, he handed over the commit access to Gavin, who then opened it up and handed off commit access also to other developers. And I think there are 5 right now, including Jeff Garzik, Vladimir, Gregory, and Gavin. And
Dr. Woolley?
Yes,
he's also
Dr. Woolley Sipper as his handle is also, that rounds it out. So that's the 5. So that's the kind of technical definition, but another kind of looser definition is people who've made significant code or protocol contributions to Bitcoin in a kind of looser term. So
to the core protocol of Bitcoin.
I mean, there are many companies that build projects and prototypes and algorithms on top of Bitcoin, but in terms of actually checking in code, particularly consensus code, which is quite fragile, but also just major changes or many lines of code that are, contributing, performance enhancements or refactoring or stability to Bitcoin.
Right, because like with Armory, we run Bitcoin Core and then Armory on top of it, and so everything that has to do with the network consensus with the Armory wallet goes through Bitcoin Core.
Actually, that's precisely the right way to do it, because we've seen, there have been a couple of projects that have had a go at re-implementing the consensus code, and it's actually quite a risky thing to do, because it's more important for consensus code to be consistent than correct. Because, if there's a small bug in it, but it's not causing any problems, it's more important that all of the implementations and all of the platforms do exactly that. Because, for example, if on one operating system, or let's say on a 32-bit system, it did one thing, and on a 64-bit system, it did something else, not in a general case, but in a particular malicious, well-crafted sort of packet to trigger that edge case, that could cause a fork in the ledger and lead to ledger corruption. And that would need to be an emergency fix if something like that were to happen. So it's very important to be consistent. And basically the specification for Bitcoin is what the consensus code does. So there are moves afoot right now to pull out the consensus critical parts into a separate library, libconsensus, and then encourage people who are writing independent, additional Bitcoin daemon replacements or full node replacements to link to and use the consensus library. And in that way, we can much more robustly guarantee consistency. There's certainly a number of companies that have tripped up over having a library in another language that has consensus code in it, and they've frequently, got flipped off the network or had to go fix their library. And there are people who will kind of make a sport of, very adversarial thinkers who think about protocol details in the edge cases, who will occasionally send an interesting, in quotes, transaction to the Bitcoin network to see which services drop off the network.
Oh, what'll happen?
Yeah, and so that's kind of.
But that's a useful. That's a useful contributor in their own way.
Definitely,
someone's got to be providing these types of tests.
So Peter Todd has been involved in Bitcoin for quite a long time, and he kind of takes delight in exploring the edges of sort of game theory and doing a very sort of adversarial protocol analysis kind of work, which is very helpful for Bitcoin. And he actually also contributed and worked closely with Greg Maxwell in some of the early thinking about off-chain things that are towards the direction of Lightning with assurance bonds and things like that. Just to sort of, set up the economic incentives so that something can happen off the chain without needing to go on the chain, because if somebody would invalidate that, they would be punished economically. So set up the economic incentives so they can operate off-chain, and then you can get to high scale. So he worked through some of that stuff. And in saying the adversarial, that's actually a compliment. I mean, I think it's actually quite difficult to teach somebody adversarial thinking. It's something, it seems
it's counterintuitive unless it's intuitive.
I mean, I think a lot of people in software in general, or, you see it in testing, they are sort of functionally testing something, which is to say, they
is it working?
Yeah, I mean, they test out the common use cases, and they're not thinking, now how would a hacker trick this system into doing something it's not supposed to do, which is a whole different ballgame of thinking. And, some people are quite skilled at that, and, their mind just works like that. They walk through life and they go through an airport and they think, well, look at that door's unlocked, or look at that, the guy's not looking at the screen, or, the X-ray machine, it doesn't work properly or something. So and
we hope they use that talent for productive uses.
Right. So, but I mean, the people that have that, you can describe a system to them and they just instinctively spot the weak point and hone in on it and ferret out what's wrong with it, right? So it's actually a skill, and Peter Todd's one of the people who's quite good at that, and Greg Maxwell is also very good at that. And I mean, Gavin was the lead developer for a period of time, and
because Satoshi handed it right off to him,
right? And I think Gavin actually has written quite a lot of lines of code up to the point where Vladimir described that he started to be less active and eventually handed over lead developer.
Well, it probably just got to be too much work. I mean, you're herding all these cats. I mean, as Vladimir said, like, making it a full-time job just to keep up with that.
Yeah.
Plus, you become a lightning rod of attention. So, you have to do interviews and travel and speak at conferences and all this type of stuff.
Right.
So, I mean, it becomes a lot of work to manage an open source project.
Yeah. I mean, I have been to maybe 4 Bitcoin conferences, 5, something like that. But there are literally, and I bumped into you at a couple of them, and we had some interesting conversations. These days, there are literally, there's a conference every week on some place on the world, and you come into people, and they've flown from the previous conference. You could just about live on the Bitcoin conference circuit, and Gavin obviously is not traveling that much, but it's certainly can use a lot of your time presenting and flying to conferences and, talking to the media and so forth. And I think there are some other people who talk.
Less talk, more code.
Yeah, I mean, that's good. Well, the cypherpunks thing, right code's what counts. But I mean, there are also some other interesting people who, popularize and talk about Bitcoin in a less technical way, or in a semi-technical way, or write books explaining details. There are a number of people in the space who specialize in that kind of thing. But certainly, Gavin did some of that stuff for a period of time, and I guess still does. Yeah, so Vladimir is sort of heads down, make the code changes, and I think people in the development community who are active have been very happy with the way he's progressed the project and kept it agile and moving forward.
Yeah, it makes me wonder. I think his PhD was in graphics cards of some type. Makes me wonder if he was mining at all with them in his research.
I don't actually know. Maybe that's his entrance to it, right?
I'll have to ask him when I corner him one of these days.
Right. Because I mean, actually, there was a good period of time there where you could make good money mining with graphics cards.
Oh yeah, I mean, I know quite a few people. They were working on their physics PhDs or in a biotechnology lab or something, and they were using their computer resources to mine a bunch of Bitcoins.
Yeah, I had a go myself, but unfortunately, early 2013 when I had a go, it was the kind of tail end of profitability on
the
mining.
GPUs.
Yeah, because the ASICs were starting to pile in, and it wasn't long before the GPUs were like electrically inefficient. So I only got a couple of months in.
So, who else do we have to kind of mention? I mean, what about Bitcoin scalability? Is there anybody done really good work in that area?
So I mean, we could start with Matt Corallo, who worked with.
But I thought he was like 12.
No, that's no. He finished his bachelor's degree, and I think he compressed it from 4 years to 3 years so that he could get into Bitcoin earlier. And actually, as I understand it, he wrote a whole bunch of code while he was doing his degree.
Wow! So
like
that's how he was so prolific at such a young age.
Yeah.
In this area.
So. And actually, there was somebody younger than Matt, Forrest Voigt, who implemented the P2Pool protocol, which is a kind of clever way to have a peer-to-peer pool behavior, so that when you have a Bitcoin mining pool, there's some element of trust, and you're using this kind of centralized infrastructure. So there's an element of centralization, and centralization tends to weaken Bitcoin's security assurances. And so Forrest Voigt had worked on making a peer-to-peer version. So it has a kind of mini mining thing going on where you send through proofs of work that are smaller than the target for Bitcoin by some degree, and it accounts for work on that basis. And so it's a quite clever interplay between a sort of sub-problem with smaller proofs of work, and then when somebody eventually finds a full proof of work, it pays out the contributors of the smaller proofs, which are called shares, directly in a way that, there's no central party needed. So when you mine on a pool, the pool collects the Bitcoins and then it pays them out later. And so P2Pool was able to do that in a relatively secure, sort of incentive compatible way in a peer-to-peer network, which is quite a clever feat. And for whatever reason, it doesn't see that much active use. I think the hash rate on it is like maybe 1% or something, but it could certainly see wider use. And I don't know how old he is exactly, but he must have been like 16, 17 when he was doing some of this stuff. So it's pretty impressive. And I think he's in university now. I don't know his exact.
Unbelievable.
So, I mean, I'd say it shows that Bitcoin is really, a meritocracy. It's really about, can you contribute? Can you understand this kind of bleeding edge cryptography and game theory and networking consensus logic, and develop, real useful code that improves Bitcoin or adds new features to Bitcoin? And so it's not about the age or about whether they have a PhD or not. There certainly seems to be a
common theme.
I didn't actually realize Vladimir had a PhD, and somebody mentioned it to me quite recently. I was like, looked it up. I was like, oh, okay, he has a PhD too.
And so many people who've left their PhD programs to work on Bitcoin.
Right.
Like Ryan X. Charles left his physics PhD.
Right.
I've ran into a lot of people, pitching different business plans or ideas to me that are, just very.
Well, I think that's the thing.
accomplished.
I mean, people are looking at Bitcoin and thinking this is, extremely exciting moment of technical innovation in the world, and it's a kind of one-off event. So they tend to sort of drop what they're doing to catch the timing of it.
Like, this is fun.
Yeah. So we also could talk about the Lightning Network, which was by Joseph Poon.
Joseph, I've only ran into him once, and I just watched one of his presentations. Mm-hmm. But man, I was like, need to keep my eye on this one.
Yeah, actually.
Why is that? It's interesting. You would have a similar kind of opinion on him. Well, I mean, why?
So actually, I should step back to Matt Corallo. So Matt Corallo, together with Mike Hearn, implemented payment channels using the Java Bitcoin library that Mike Hearn had developed as a kind of starting point. And micro payment channels are quite interesting, but they're point-to-point and unidirectional, so you tend to exhaust them, and they're mostly useful for sort of recurring streaming payments or something like that to a video streaming service or something. Now, there were ideas about creating a payment hub so that you could route payments through a hub and possibly do it in a way where you wouldn't have to trust the hub with your money. But it's still kind of limited because it's unidirectional. So every time you run out of funds on a channel, you have to go back to the blockchain and start another channel. And so it doesn't, it kind of keeps using blockchain transaction space. And so the kind of thing that came out of left field and surprised people when Joseph Poon and Thaddeus Streicher released the Lightning white paper is that they'd found a way to significantly move that forward on like 2 or 3 fronts. So
oh, wow.
The first thing is that the channels are reversible. Okay. And actually, yeah, so I'll come back to that in a minute. And secondly, that they found a way to, so they proposed the idea that you could rebalance channels. So if each user maintains multiple channels to the network, to different nodes, and a node in the network that is providing service runs out of funds on one channel, it could pay another node or a user negative fees to sort of do a contra trade where, they pay themselves. So they pay the node money back and they receive corresponding funds on another channel. And that would enable the node that's trying to provide service to regain access to funds to continue providing service. So they're willing to pay somebody to rebalance because then they can onwards sell that payment routing to a paying customer kind of thing. And that kind of adds the possibility of sort of higher velocity, longer lived movement of funds within the network without having to hit the chain. Because even though the channels are now reversible, if there's a net flow in one direction, you could still run dry. If users keep buying things and you can't refill them. But it opens up the possibility for a sort of three-way trade, So if I'm a user and I keep going to Starbucks, I put $100 on there and I keep buying coffee and I kind of run out, right? So what does Starbucks do with the money? Well, they're paying people in US dollars. They probably sell the coins. And so when they sell the coins, they sell it to an exchange. And what does the exchange do? Well,
they sell it to you.
They
go buy more coffee.
So they sell it to me and I need to buy some more Bitcoin. So I go buy it. So that kind of triangular trade, that doesn't have to hit the blockchain. That can recirculate in Lightning, right? So if you figure out a way to kind of put that all together, you can make that work. And so there's somebody else working on, we should just finish with the Lightning. So Joseph Poon and Thaddeus Dreiger proposed this. And Thaddeus, you were talking about PhDs. There's somebody else I saw on his CV, though I don't know him that well, that he was partway through a PhD. And you have to wonder if that was another kind of
diverted.
Bitcoin is too exciting. I have to put this on hold kind of thing. And so about Lightning briefly. So I mentioned the reversible payment channels. So it turns out there's a guy called Christian Decker, who is a PhD student at ETZH, which is a kind of prestigious technical university in Zurich, Switzerland. And he invented something called a Duplex Channel, which is a component of Lightning. And actually he kind of invented almost the same thing as Lightning, possibly slightly before Lightning, but because he put it through the peer review academic publishing channels, Lightning came out and reached public awareness before his publication date. So I think he was kind of chagrined that, they stole the limelight and he had a similar idea. And so,
early bird catches the worm.
Yeah. So Christian Decker is another interesting story, which is he was involved in Bitcoin quite early and he managed to, he was in university and he managed to persuade the distributed computing research group at ETZH to allow him to do a Bitcoin focused PhD. So he's finishing his degree, I think, in a few months.
He'll probably be the first Bitcoin PhD.
Exactly. I believe that will be the case.
Isn't that cool?
And I think, I don't know too much about the research group there, but I think people talk about Bitcoin and there being a patient zero, so somebody who introduced many people to Bitcoin and then people get excited and they introduce other people. So I think Christian Decker was kind of the start of that distributed computing group, having more people researching Bitcoin and getting interested in Bitcoin. Because, in the early days of it was very, very early days, and it was kind of left field thing to persuade an academic distributed system guy that, I want to do a PhD on this topic, because it sounds like some kind of open source project and maybe not in line with the usual things they would research.
Not to hijack it, but how about Dr. Timo Hankey? I think he's PhD in cryptography, and he had done some very innovative stuff when it came to the actual cryptography and the mining. Maybe you had some comments on that.
Yeah, so I talked with him a few times. I met him at the Financial Crypto Conference, and I think also at one of the Bitcoin conferences. And as you say, he was actually a professor of computer science at German University with a specialization in cryptography, and he took a hold on his career to do Bitcoin.
Yeah.
So
I remember because he was asking me about it.
Not just to students, but actual tenured professors for Bitcoin has the draw. So he worked for Cointerra, I believe, and actually I think he relocated from Germany to the US, and I'm not sure they're in the US somewhere where they were, particularly to help with optimizing the proof of work in silicon. So obviously the the mining equipment, it's aiming for electrical efficiency. And as we've gone through, as we came off the tail end of graphics cards and got into ASICs, they kind of, the Bitcoin ASIC industry blew through like decades of chip advancement, going from 130 nanometer, 65, 40, 28. Now there are a couple of companies at 22 and somebody trying to do 14 as well. So part of the, it's really fierce competition because Bitcoin mining is a kind of mirrors sort of commodity mining economics, where it's sort of, it's a race for efficiency, and the most efficient player wins. And so it's not just a matter of moving to the next process, but I know some of the manufacturers are on their sort of third generation or more on the same process. So even on 28 nanometers, there have been moves that have gone, within like a factor of 4 in electrical efficiency improvements, just by sort of micro optimizing the cryptography, trimming off unneeded outputs on the beginning and the end of the SHA-256, loop unrolling, and just optimizing the circuit and rearranging things to minimize electrical use, and also sort of hand layout. So people who don't know about hardware maybe, but there are sort of high-level definition languages. So the easy route is to use the high-level definition language, use the library provided by TSMC or the chip, the sort of process provider, and compile the thing, test it in a simulator, and hand it off. And that gets you a certain way, but in the same way that on a CPU you can usually get quite a bit more performance by hand optimizing the assembler, there's an analog in the chip world where you can go to increasing levels of sort of manual expert layout. And there's some extremely clever people in the electronics and chip manufacturer side of this business who are really kind of pushing the envelope of electrical efficiency. So it's all kinds of interesting innovations that have Bitcoiners kind of helped motivate.
Help start. Well, I suppose we could go on forever. Just, there's Sergio De Lerner, Manuel Aros, Jeff Garzik over at BitPay. Gosh, who might be some others that have made some good contributions? Not that we need to go into too much depth of what they've done.
All those people you mentioned, Sergio actually, I think, maybe there's another Bitcoin PhD. He did his PhD in some kind of smart contracting and cryptography to play fair games, like to do cryptographic.
Sergio did?
Yeah.
Oh,
so
interesting.
His PhD is, I think it's ApeCoin or something. So he has a whole protocol for playing different games, including poker, and doing it in a way there's no house edge and there's no, you don't have to trust anybody, and it's all enforced by the network.
Yeah, and there's Dr. Groninger. He had been over at Kraken, has a PhD in quantum physics.
Oh yeah, so I think he
mechanics,
implemented one of the libraries. An alternative implementation or refactoring of Bitcoin, and has done some other work. Now, so somebody else who's done a bunch of stuff is Rusty Russell, who is a Linux kernel developer. He wrote much of the sort of significant part. I mean, I'm not from a Linux kernel background, but as I understand it, he wrote significant parts of the Linux networking stack, and has been working on Linux kernel stuff for something like 18 years or something.
Wow.
And he got interested in Bitcoin sometime last year, I think, and took a sabbatical from IBM, and where he's working on Linux kernel stuff, and implemented a sort of sharding, high scalability approach that possibly could be applicable for Bitcoin. So he's now working on the Lightning Network and the sort of routing of payments. And the routing is not just about shortest path or best latency path and reliability characteristics, but also about the cheapest path in terms of the fees that the nodes you would route through are advertising. So he's working on that, and it's a great thing for Bitcoin that he is, because there are probably few people in the world that can touch him in terms of low-level network and routing expertise at the implementation level.
And it just goes to show just how much of a community effort Bitcoin is, and just how many really talented and gifted computer scientists and just across the whole spectrum in Bitcoin. I mean, we've got ourselves $1 billion a year industry. We've got a lot of people making their livelihoods in this field, and a lot of people driving forward the very cutting edge of computer science and networking and monetary theory, all of these things. There's so much fun and a lot of camaraderie too.
Yeah, I mean, it's there's a lot of impressive work being done over the last few years on really improving the performance characteristics and refactoring, re-architecting the CPU memory footprint and the algorithmic complexity of the code, and sort of major new protocol upgrades. So Greg Greg,
because I mean, it needed a lot of work.
Yeah.
I mean, Satoshi had released it, but even Gavin, I mean, he was pretty much all by himself. When you look at the GitHub commit history,
Yep.
it needed a lot of work, over the last 2-3 years that a lot of that work's been done.
Yeah, so Greg had mentioned to me recently this fact that so when you join a new node to the network, it catches up with the entire transaction history. And so he mentioned to me that there had been 4 times, I think it was, through the history of Bitcoin, where the transaction, to catch a new node up on the network had taken about a day. And somebody done a bunch of optimization and got it down to an hour. And then, as more transactions are piled on and more users, so that the blocks were fuller, it kind of bogged down and got back to a day again. And so Peter Wall did the most recent one with the headers first, a much faster kind of major refactor of the kind of block catch-up algorithm, which was an extensive piece of work. I mean, it took a long period of time. And that's been now very effective, rolled out relatively recently, and allows a full node to again catch up in something like an hour or two, depending on your network and CPU and so on. But I think the interesting thing there is that we may be at the end of the line almost, because at the beginning there was a huge wish list of things of varying complexity that could be done to optimize this particular part of the protocol. And I think it's almost at the end of the line that there's really not that much more that you can optimize about that. So at this stage, it comes into the sort of throughput and scale discussion that from here forth, the kind of block catch-up will get slower, and there won't be that much more we can do about it other than sort of bandwidth increases. And there may be a couple of minor things, but nothing major left.
Well, I'm sure that as a community, as Nick Sasvo said, we need good, solid, hard work in the computer science to really solve a lot of these problems, because we've got a production system, billions of dollars of value at stake, a lot of people building on top of it, and yeah.
So, I mean, you mentioned Nick there, so he's obviously somebody quite central to this whole picture, Nick Szabo. So, as we mentioned in the previous episode, he invented a number of kind of contributing things to Bitcoin, including smart contracts back in 1995, and BitGold, a kind of Bitcoin precursor that was an outline design with some kind of human markets element as its inflation control. And he's been quite active in Bitcoin, trying to add a kind of, he's a computer scientist, and trying to add a more formal dimension that, it's a system at this point with a very large amount of money dependent on it, and, changes that we made should come with, security proofs and empirical data and analysis and so
and
forth.
Testing and simulations.
Right.
We're not just playing kiddie ball anymore. We got to have real solid computer science and testing and professionalism done with anything we want to do as we extensify it. Thanks so much for going over some of this, going over some of our major contributors here in Bitcoin, and for taking the time to do this week with Dr. Adam Back. I think a lot of people will find it very helpful and insightful in where Bitcoin has come from and where Bitcoin's going to go. So thanks for being with us, Dr. Back.
All right, thanks.
Be sure to get a copy of the free Bitcoin Guide at freebitcoinguide.com. Got a question or suggestion? Record your voice at bitcoin.kn. Don't be shy. To help the show, share bitcoin.kn with friends, post about it on Reddit, and otherwise spam the interwebs. Your iTunes comments and 5-star reviews are very important to us. Please continue tuning in to the Bitcoin Knowledge Podcast, where we release interviews with the top people in the Bitcoin world. Now take some choline and let that Bitcoin knowledge consolidate.